For this example, we are determining the convergence or divergence of the sum from n equals 1 to infinity of negative 1 to the n times n divided by the natural log of n plus 1. We will view this as the sum from n equals 1 to infinity of negative 1 to the n times a sub n, where a sub n equals n divided by the natural log of n plus 1. Notice for n greater than or equal to 1, the natural log of n plus 1 is greater than or equal to the natural log of 2, because the natural log function is an increasing function, and this is a positive value. Further, since n is greater than or equal to 1, n is positive. So, a sub n is the quotient of two positive values, which makes a sub n positive. And that means we are indeed looking at an alternating series. We want to begin to look at convergence and divergence by evaluating the limit as n goes to infinity of a sub n. That is, we have the limit as n goes to infinity of n divided by the natural log of n plus 1. Now, as n goes to infinity, our numerator clearly goes to infinity. Likewise, our denominator, the natural log of n plus 1, will also tend to infinity. So we have an infinity over infinity indeterminate type. That means we're going to apply L'Hopital's rule, and we'll take the derivative of the top and the derivative of the bottom. So we have the limit as n goes to infinity of 1 over n plus 1, which is equal to the limit as n goes to infinity of n plus 1, which tends to infinity. So while our alternating series test will not tell us convergence or divergence, the divergence test will tell us that this limit does not go to 0, so the series will diverge.